Hey everyone, welcome back to Deterministic. I'm Brandon Konkle, and this channel is where I explore different ways to embrace more determinism in our programming, trying to combat chaotic production errors and make our applications more reliable. This is episode 2 of the Rust review show. This is going to be a regular show where I review articles in the Rust community over the last week or two, summarize them, and talk about why I found them interesting. And this week we have a great set of articles. There's some interesting stuff that's been posted in the Rust community over the last week or two. Again, many of these articles you can also find in the This Week in Rust newsletter. I will say this time the majority of the articles I found before the newsletter came out, but several of them are still there. So if you haven't checked out This Week in Rust, definitely take a look. So starting us off this week, we have announcing Rust 1.64. This is from the official Rust blog, and it's talking about the changes that have landed in 1.64. There's not a lot, but there are some interesting things here. So kicking us off, into future. This is a new trait that changes how await works. So now, instead of just futures, await can await anything that can be converted into a future. So they provide an example here of abstracting away the send step of a storage request. And to do so, they automatically convert the request into a future by implicitly calling send behind the scenes. So this can allow for more ergonomic developer experiences. So making things more convenient, avoiding, like you can see here, we're able to skip a whole line here because that is done implicitly. So you can imagine this very simple example can be expanded to a lot more complex things to kind of streamline things, allow you to convert to async, and kind of take advantage of this syntactic sugar around how async works. There was another great article going in depth about async that I'll cover next, so more to come there. But also in this 1.64 update, we have C type aliases like cuint or culong that are already available in the standard library. But when you're working in a really constrained embedded context where you don't want to include the standard library doesn't work or includes way too much bulk for some of these really constrained embedded scenarios. So this moves those type aliases into core and alloc. So that way they can be used in these scenarios as well. There's also a change to Rust Analyzer, making it easier to install and making it now available as a Rust Up component, as you can see here. And then also a change to cargo packages and how workspaces work. They can now inherit common field values. So things like version numbers, repository URLs, Rust version, things like that. From the workspace by using a workspace.package or workspace.dependencies files. This kind of reminds me of mono repos in the Node or the TypeScript world and how they'll often inherit from a top-level package JSON. So this seems like the same kind of approach here. And then, let's see. Oh, you can also pass multiple target options into cargo build as well. There's a number of other things, methods and trait implementations that were stabilized, and a few other improvements and changes that were called out here. But overall, seems like a solid release that's adding some new functionality. Check it out. Next up, there we go. Needed to find the right button. Next up, we have the article that I just talked about, Why Async Rust. And this was an interesting post by... who is it? Joshua Whites. I'm sure that I am saying that wrong, but my apologies to the author of this post. It's a great post, though. You should definitely check it out. He is a Rust developer advocate at Microsoft, and he posted an in-depth article on last Monday, clearing up what he sees as a common misunderstanding around the value proposition for async. So conversations around why async, he says, often focus on performance, but this is really just one aspect of async, and it's highly dependent on the kind of code or the kind of workload that your code is doing. So you only tend to notice performance when things are performing badly. So his article instead focuses on benefits that are unique to async, functionality that it enables that you can't get when you're using non-async Rust. So first of all, let's see, where is... Trying to find the right spot. Yes, okay, he's talking about async under the hood. He summarizes the core feature of async as a way to return an intermediate type, a future with a poll method that will eventually give us the value that we wanted or indicate that it's failed. So await is, so that's async, that's one side of things, but then there's the await keyword. And so this is a way of compiling down that async function and all of its await points into a state machine, which knows how to suspend and resume from the various points. So this provides a way to abstract away that underlying poll detail so that it resembles non-async code in Rust. You don't have to think about that or manage that. Instead of a function call synchronously returning output, the function call instead returns this container for an operation that'll eventually yield output, and then it manages the state machine of execution behind the scenes and the flow control around that execution. So with this computation encapsulated within that future, we gain access to a variety of different operations that we don't have access to in synchronous Rust. We now have control over that computation, the execution of it. We can suspend it, we can cancel it, we can pause it, we can resume it, we can even execute things concurrently, which is a big deal. This is a big part of async. And we can do interesting things by combining cancellation and concurrency, like racing two computations and accepting the one that completes first while canceling the slower one. Or we can add timeouts to our computations and cancel it if it doesn't complete within a certain amount of time. So we can do more with async to customize our approach depending on the kind of workload that we're handling. And we can do more to optimize performance based on what that workload really looks like. He also provides a really helpful a really helpful distinction between concurrency and parallelism. So I love how he calls it out here. Parallelism is a resource. Concurrency is a way of scheduling computation. So for example, if your computer has 2 cores, the maximum amount of parallelism you're generally going to have is 2, because it's 2 cores, so you can have 2 parallel computations executing at the same time. But concurrency is different. Even on a single-threaded machine where you can only have one maximum level of parallelism, one computation running at one time, you can still pause and resume that. So you can interleave that. You can work several computations together. And this is especially helpful when you're talking about input-output, when you're talking about waiting for a network call or waiting for reading something from disk or a stream or something like that. In those cases, you can execute and check to see if your request is done, and if it's not done, then you pause the execution and then you move to something else on the event loop and check to see if that's done. This is the approach of the node event loop, and so that's what he's talking about here. Async is more than just performance. It's about being able to interleave these workloads and customize it based on how they work, how I/O works, take advantage of both parallelism and concurrency. And he talks at the end of the article a little bit about the ecosystem. I think this is a bigger deal than he makes it in the article, but he's already spent a lot of time here. But he talks about how the ecosystems that are coming out allow for a great deal of flexibility. And I agree. I think Tokio is really great for certain workloads, and you've got to understand how Tokio's event loop works to understand which kind of workloads work well for it. And then some of the other async systems out there might be better suited for your type of workload, or you might want to go down into a low-level implementation working with futures, and you've got the flexibility. You can make the choice, but there are incredible tools out there like Tokio in the ecosystem that you can take advantage of. He finishes up with a defense on how focusing on the features that async enables rather than solely on the performance that it can provide gives you more insight into the value that async actually brings. So overall, I think it's an excellent article. It proves that async await is about more than just speed, and in fact, speed is kind of dependent on what you're doing with it, and that might not even be why you use async in a certain situation. Oh man, it's got all kinds of notes and references. I love that. This is a great article. Check it out. Next up, we're going to talk about Cargo Careful. So Cargo Careful is a new library from the maintainer, he didn't create Miri, but he definitely contributed heavily to it. Ralph Young. Okay, I'm not sharing the screen yet. Let me pull that up. There it is. All right, Ralph Young. I believe I'm pronouncing that, but I don't know 100% for sure. So again, apologies to the article or the author if I'm butchering your name. But Ralph Young is a postdoctoral researcher at MIT. He's a regular contributor to the Rust compiler, and he's a soon-to-be professor at the world-renowned ETH Zurich University. He shared this new project, Cargo Careful, which builds a version of the standard library with a variety of extra debug assertions that are not included by the version of the standard library that is distributed in RustUp when you're installing Rust. So this means that when people are working on the Rust standard library, there's a wealth of additional debug assertions of invariants that are available, that are in the code, but they're not exposed in the default version of the library that's built by RustUp. So this builds it with those debug assertions and runs your project with that, essentially running it extra carefully, including all that additional debug checking. Comparing this with Miri, which is, if you haven't seen it before, it's a really popular and widely praised analysis tool for detecting undefined behavior, that kind of unpredictability that I hate in the more dynamic languages. It still happens in Rust, but it's a lot more rare, and the Miri tool is a great way to analyze things in depth to catch more undefined behavior even than the compiler catches by default. But it's slow, and there are situations where Miri can't run, some of those embedded situations like I've talked about before. So Cargo Careful is like a middle ground. This is significantly faster than running your program in Miri. And it also supports foreign function interfacing. That was the big thing that Miri doesn't. You can't use FFI in Miris. So that would be a reason that you can't run Miri on your project. So Cargo Careful is a good fallback in that scenario. It's still pretty early days for the library, but he talks about potential improvements in error handling and things like that. But for now, it's definitely a good tool to turn to if you can't use Miri on your project. Next up, this was an interesting article from Volvo. Why Rust is actually good for your car. This is written in the form of an interview between two people at Volvo. Pop it up here. All right, there we go. So Johannes Fufas, again, I'm terrible at pronouncing names, so I apologize. He's the interviewer, and Julius Gustafsson is the interviewee. So yeah, he is a technical expert and system architect at Volvo. And the interview is interesting. He talks about how he came to Rust and talks about a revelation that he had after joining a team with a really well-crafted and highly polished C++ code base. So after joining the team and struggling with the same kind of obscure memory issues that he's always had in other code bases, he thought to himself, is this as good as it gets? Is this how my whole career is going to be? Am I going to spend the rest of my life debugging these same kind of obscure memory issues? And this really hit home for me because I've had that same kind of feeling. No matter how carefully curated the TypeScript or Go or Python code base is, it seems like we're still dealing with a lot of the same unpredictable production issues as on any other project. And I want to find a better way. That's my whole concept around the deterministic channel, is that there's got to be a better way. There's got to be a way to embrace more predictability up front. And at Volvo, they've decided that Rust is the way. So his first project at Volvo was to build an Android hardware abstraction layer around their signal broker. And he built it using Rust and async futures. And what stood out to him was how everything just worked from the start. He says, if your logic checks out, you can generally trust it to work if it compiles. I would say testing is important. Unit and integration testing is important in supplement to that, because there are a lot of cases where your logic isn't checking out. And so you definitely have to exercise that and make sure that your logic handles every possible case. But once you've got your logic solid, then generally the execution is solid. Overcoming tricky compiler errors can be challenging, but the confidence of Rust's sound type system and careful memory management makes it all worthwhile. So He appreciated Rust's memory safety right from the beginning, saying that he generally didn't have to think about race conditions or memory corruption anymore. But as time went on, he found other things to appreciate too. He found things about the language and its ecosystem that he loved, things like refactoring. Refactoring is easier because anyone can generally play with the code base and try to improve it. And as long as the code compiles, as long as all of the invariants, the kind of unwritten requirements in other code bases that only a few people know about, as long as they're satisfied, it's generally going to work. Because of the lifetime and ownership model enforced by the compiler, it's generally easier to use third-party libraries because Rust has a built-in package management tool chain, so build issues aren't nearly as much of an issue, and it holds those same packages to the same memory safety standards that your own code are, so you don't have to make assumptions about the memory model that they're using. He's got a list of kind of things that you have to think about when using a C++ library that is completely covered in Rust. So he says that, he says that, closes up by talking about how Volvo wants to expand their use of Rust and no longer use C for new work, which is an attitude that is starting to spread. I'll have another article here talking about that kind of idea that C++ may be deprecated. But he says Rust still has some rough edges and it still requires you to make certain trade-offs that might not always be best for your use case, so you got to pay attention, but it has huge potential for higher quality code up front at a lower cost. And he says this is going to reduce Volvo's warranty costs long term, so it's a win-win for their bottom line. All right, so what I was just talking about, is it time to retire C and C++ and prefer Rust in new programs? My launching off point for this is an article from The Register, a longtime independent tech news outlet. And they posted an article this week in response to Microsoft's Azure CTO, Mark Russinovich, tweeting that it's time to halt starting any new projects in C and C++ and use Rust instead. So here's his tweet. Obviously, it got a lot of attention. I love the proclamation they make here, though. Them's fighting words. But they speculate that the impetus for this tweet was Linus's conversation about Rust entering the Linux kernel in v6.1, which I had talked about last week. Essentially, they're saying if the Linux kernel developers, the programmers in the most successful C project of all time, are embracing Rust, why not everyone else? The author of the article generally agrees, citing Microsoft and Google's admission that a large portion of their security vulnerabilities are caused by developers making memory corruption mistakes. He points out that this is going to be a very long transition, though, and I think that is an apt observation. I come from the Python community originally. My first jobs in my programming career were around Python and the Django framework, and many of us thought that the estimate of a decade to see broad Python 3 adoption was radically overblown, but I failed to consider the power of legacy code. The reality of that Python 3 adoption was that it's still dragging out. The author makes the point about COBOL. So there are still COBOL projects in regular use today. There are still people maintaining COBOL code in mainframe situations. So if that's still a thing, then C and C++ will likely still be take a very long time to fade away. But this is exciting to see the community starting to embrace Rust. The influence of bringing Rust into the Linux kernel is really starting to make a difference in people's perception of Rust and how production ready it is. Next up, a video. This is the latest Crust of Rust video. I'm sure he said his name somewhere in the video, so it's unfortunate that I don't remember. I apologize. But he posted a new Crust of Rust episode on YouTube, digging into build scripts and foreign function interfaces. So FFI is the way to get Rust to interact with code written in other languages. And he also talks about reverse FFI, which is the counterpart, using Rust code from other languages, making a call from another language to Rust code. So John is the author of Rust for Rustaceans, digging into Rust in depth, and he works with AWS on Rust. He posts these in-depth videos on YouTube and Twitch that dive into real-world examples and show off realistic working code, which is cool. Not all the tutorials out there go as in-depth as he does. So John is really easy to listen to. He does a good job of diving into these real examples. He looks at some popular sys crates like libgit2sys or libssh2sys or OpenSSL sys. And he also demonstrates how to write your own bindings against the libsodium-C library, covering things like bindgen and autocfg and reverse FFI like I was talking about. I'm just really impressed with how in-depth his tutorials are. This is over 2 hours. So make some time, set aside some time and check that out on YouTube. All right, I've got 2 more articles. Next up is multi-threading in Rust. So this is an article from Sylvain Kirkour. It is an excerpt from his book, Black Hat Rust, that he posted on his blog this week, introducing multi-threading in Rust and using the example of TCP connections. He talks about how Rust's type and ownership system helps prevent data races and allow easier and safer concurrency, so giving you more confidence when you're multi-threading. Multi-threading is something that is fraught with peril in most languages. It is really easy to introduce memory corruption or to reference something that's already been deallocated or things like that. It's definitely challenging, but Rust's memory ownership system and the borrowing tracking that it does really helps give you more confidence to make this more stable and reliable. So he goes on to introduce a little 2-line change to the code that he was using. So really it's just changing into iter into interpar iter, which means into parallel iterator. But this change hides some complexity underneath, behind the scenes. So he talks through what's actually happening, making that change, what this actually does. And he finishes up by comparing multi-threading to async await and touching on when async might be a better approach. So generally, the article is over pretty quickly, but it's densely packed. It's got a lot of information and rationale about his point. All right, so finally, I'll finish up with a tutorial. So this tutorial comes from a product company that I'm really interested in. I was a big fan of platform as a service. I loved the abstraction that Heroku provides, but over time, Heroku has changed. A lot of people are starting to look for alternatives. Shuttle is an alternative that is built specifically for Rust up front and allows you to use the type system, to use traits, to configure your deployment of an application on the Shuttle platform. So I personally haven't used Shuttle. This is not an advertisement for them. But I'm definitely intrigued by the idea. I've really wanted to see a platform as a service customized for Rust. And this article, written by their engineer Ben, goes into creating a Discord bot in Rust using the Serenity library. But then he also reaches out to the AccuWeather API. And generally, this article is just the kind of like screenshot and code heavy kind of article that I like to write myself. I love really practical examples up front. And so he walks through how you respond to a chat command, how you make the call out to the API, how you return the response back to the user, and then closes out with a mention of how to deploy it, how to use the cargo command that Shuttle adds to actually push it out to a running server. Like I said, I've not used Shuttle, so I can't vouch for its quality, but I love the idea of using type contracts and traits to help configure a runtime application. It feels kind of like Lambda functions and kind of the contract of invoking a Lambda function that AWS uses. I like the concept. I think it's an interesting idea, and this article is really detailed on how to set up this kind of typical chatbot interaction with Discord. Check it out. All right, so Went through, how many articles was that? That was 8 different articles this time. I think there's been a lot going on in the Rust community. I'm loving doing this show and making sure that I stay up to date on everything and kind of getting an idea of what's changing or what the perspectives or attitudes are around different things. It's exciting to see Rust overtaking C and C++. Anyway, check out these articles, check out the show notes, and you'll find links to all of them there. Let me know what you think in the comments. I'd love to hear what I got wrong, what I missed, what I completely misinterpreted, or what I got right. What is a good perspective here? Let me know. I'd love to have conversation in the comments. And thanks for joining me on Deterministic.